Good morning, everybody. Welcome back to lecture number 18. Homework 3 is posted, and as you can see, you just solved this problem 2, which is a checkpoint, okay? There is also another question that asks you to plot using MATLAB, Python. We did plot, صح? So watch the videos, okay? I forgot when it's due. I put it in the announcement. March 1st?
Yes.
Something like that. Okay? Any question about the material so far? Okay. Can I have my calculator, please? Because I need to use it today. Okay. So today, we will continue Today we'll continue our discussions about what? Impedances. Do you remember this table? Do you remember this table? For a resistor, the impedance Z equal R. For an inductor, Z sub L equals J times omega. Omega is whatever before the T in the sinusoidal expression times L. For the capacitor, it is 1 over J times omega times C. Do not use the second one, okay? So, complex impedances for series and parallel. For if you have Z sub L, Z sub C, and R, impedances of the inductances, capacitance, and resistances are combined everything together, okay? And when you combine all of the Z's, you treat them as resistors even if they are capacitors. What I mean by that, do you remember when I told you if you have two capacitors in series, you add them as if they were parallel? However, this is not the case once you calculate what? The impedance. Because if you calculate the impedance, you already have 1 over J omega C. So if you see a capacitor, one has 1 over J omega C1, 1 over J omega C2, and you combine them, it's going to be 1 over J omega C1 plus 1 over J omega C2, which is Z sub C1 plus Z sub C2. You add them as if they were resistors once you calculate the impedance. If he's asking for effective capacitance, which is different than the impedance, then yeah, you treat series capacitors as if they were parallel resistors. But the impedance of capacitors is treated exactly like resistors. Get it? Hatem, did you get it? Okay. Do you remember if you have capacitor, they are in series. I told you to add them 1 over C plus 1 over C, and then you take the inverse. This is if he's asking for capacitance. If he's asking for the impedance, which is Z sub C, اللي هي 1 over J omega C1, you add them together. يعني لو كان هذا 1 over J omega C1, هذا 1 over J omega C2, the equivalent one is the series combination. كأنها مقاومة يعني. هذه الامبيدنس. Impedance is different than the capacitance. Why? Because the impedance has a unit of ohm. The capacitance has a unit of farad. But if you have two capacitors, C1, C2, C equivalent is 1 over C1 plus 1 over C2 inverse. هذه بس على capacitance. The impedance, they are treated like resistors. Get it? Get it, ya Hatem? So that's what is meant here. Recall that we combine capacitances in series as we do for resistors in parallels, but the impedance of capacitance are combined in the same manner as resistors. اللي أنا شرحتها هنا. Who doesn't get it? Example. Let's say we have an inductor and a resistor and an inductor in series. What's the first step? We are professionals, right? We find the equivalent Z's. So what is Z sub R? It's R, which is what? 100 ohms. What is Z sub L? J omega L. What is omega? Omega is 1000. What is L? 0.1. The answer is what? J 100 ohm. So if you're looking at the terminals A and B, Z equivalent equals Z sub R in series with Z sub L, which is equal to 100 plus J times 100. What's the unit? Ohms. Get it? So you have to convert from, for the inductors, you have to put them as what? Impedances. Get it? Let's go down. Another example. Let's say we have a capacitor, and then we have an inductor, a resistor, and then we have another resistor, and then we have an inductor. We are professionals. What's the first step? Right, the impedance equivalent circuit. Get it, ya Asim? Who's Asim? Get it? Get it, ya Muhammad? Khaldi?
Yes.
Rahman, get it?
Yes.
So how to write it down? We have a capacitor and a resistor. A resistor and an inductor. So the capacitance is 12.5 microfarad. How to calculate it? It's 1 over J omega C. So you have to put 1 over J times, put it in complex, don't forget, 1 over J times 1000 times 12.5 micro. That will be what? Minus J times 80 ohm. Get it? The resistors, they will stay the same, 200 ohm and 100 ohm. For the inductor, it will be 0.1 times J times 2 times 1000. So it will be what? J times 100 ohms. Okay? Then we have to find the complex impedance or the equivalent impedance, which will be what? Between A and B, Z sub equivalent. So Z equivalent is Z sub C in series with the parallel combination between, let's call this R1, let's call this R2, Z sub R1, which is in parallel of the series combination of ZR1 plus Zn. I'm gonna repeat again one more time. The Z equivalent is Z sub capacitor in series with the parallel combination between the 200 R1 and the series combination of R2 and L1. Get it, ya Hatem? So how to calculate? It will be what? Minus J times 80 plus the parallel combination between 200 and what is the series combination between 100 and J100? It will be what? 100 plus J times 100. Now I need to find this parallel combination. How to find this parallel combination?
1 over 200.
We have to do the same thing with the calculator. It will be 1 over 200
Plus 1
plus
over
1 over
100 plus
100 plus J times 100,
all inverse.
and then you all inverse. So it will be 80 plus 40J. So that is 80 plus 40J. And then you add to it minus J80. The final answer will be 80 minus J40 ohms. If you find the final answer, it is 80 minus J40. You don't have to find the phasor. You don't have to convert it. You can keep it like that. Okay, because that's a complex number. Who didn't do it by a calculator? Yes.
كيف اكتب الجي بالحاسوب؟
It is
شفت انت.
inch, the word inch or I, in the complex. So once are you in the complex domain, you just type it like that. It's an I. Remember, it's an I, okay? But electrical, you get it? Why you did not get it?
After we find out them, we represent them on a box or.
Yeah, you represent them in a box. Or you can represent them this way. You can represent them as, if you want to draw them, you can read, finally you can draw them as, I'm going to show you the ultimate way to draw them is the following. You can draw them as a resistor of value 80 and a capacitor of value what? Minus J40. You can draw them also like that. Or you can draw them as a box. Who didn't get it by calculator? Did you get it? This is very important. This example is very important to solve the homework, okay? Get it? Did you get it, ya Hatem? You don't know how to do the J? It's time to learn.
تحطها after مو before.
You have to do 5J. No, you have to put mod 2 complex. Now we have it in complex. So 2J plus 3J, it will be 5. Okay, try to do it by a calculator. Examples. Yes.
It gives me a different result when I try this.
Because something is wrong. Why it gives you?
It's supposed to be 80, right?
No, yeah, Sheikh, it's 200, 1 over 200. Why you put 100?
Okay.
This one. Okay? A voltage of, we always check its
Phasor.
cosine. Okay? Sadiq? You always have to know, you have to check it's a cosine. If it's not a cosine, if it's a sine, you have to convert it. So 100 cosine 200t. What's omega? 200. It's whatever before the t. Everything before the t is applied to 0.25 inductance. Note that omega is 200. Find the impedance of the inductance. What's the impedance? J omega L. J times 200 times 0.25. Okay? Which is J times 50. Now, what is the current? The current is, you have to write the voltage as phasor. So in this exercise, what's the voltage as a phasor? A voltage as a phasor, it will be 100 angle 0, right? So V sub L phasor equals 100 angle 0. And what is Z sub L? It's J50. And I told you J is what? 90 degrees. So it will be 50 angle 90. So what is I of L? I of L is V of L over Z of L, which is 100 angle 0 over 50 angle 90. That is 2 angle minus 90. It's 2 angle minus 90. We divided 100 angle 0 over J50. Or you can convert it to the phasor, which is 50 angle 90. You see, if you do it by phasors, it's easy to subtract. It's 0 minus 90, 100, divide by 50. If you don't know, stick with the calculator.
We treat impedance as ohm or.
We treat, this is in ohm, this is in volts, this is in amps. Okay? So this has a unit of ohm, this has a unit of volts. Thank you. Misha.
ليش قلت إن الفولتج 100 degree zero؟
Because there is no phase shift inside the cosine. So it's 100 angle 0.
وإذا كان في angle أقسمها على الانجل ولا؟
If there is a 30 degrees plus 30, you have to put 30 here. Get it? Now he's asking you how to plot it. So 100 angle 0 The current is what? 2 angle minus 90. Length of 2 angle what? Minus 90. So who's leading? Voltage leads the current. شوف الزاوية الحادة, then you decide. Example, exercise 2 is similar for the capacitor. I'm not going to solve it. It's 1 over j omega c. You will get minus j50. If you divide, then you will get plus 90 here. So it will be the current leading the voltage. Current is leading. Okay? For the resistor, they have the same angle because you divide 100 angle 0 over 50 angle 0. That will be 2 angle 0. So they are in phase. This is a very important slide that summarizes you the behaviors of every element that you see. Whether it's a capacitor, whether it's an inductor, whether it's a resistor. This is the ultimate exercise that explains what impact of a circuit element. Now, if you combine all of them in one circuit, someone will try to push the current down, someone will try to push the current up, and the resistors will try to keep the current the same phase with the voltage. And I'm going to talk about a concept in real life. In power systems, they have capacitors to correct the angle of the system. They have inductors, they put them in the system to correct the angle of between the voltage and the current. The angle between the voltage on the current and the current determines different values such as the magnitude of the voltage, the quality of your power that's transmitted in the system. So that's what's happening in real life. Is once you combine them, you expect what? Complex numbers gain. So you have to be professional in dealing with complex numbers. And if YouTube, if you have a problem with complex numbers, please contact me because you will fail the course if you don't know how to do it. We'll bring you 10 questions in Major 2. If you don't know how to use the calculator, you'll get 0. Or maybe 2 out of 10 because you got lucky in Major 2. Please, if you don't know how to use the calculator, come to me. If you cannot buy a calculator, I will lend you my calculator. Please. You cannot survive Major 2 without complex calculator, okay? One of you from the other section had a calculator that does not have complex numbers. So please, from now, make sure you try to solve it. Please, this is very important, okay? I'm going to take a break, tell you one important news. So what did we agree about the courses? Next Tuesday, we will have 2 lectures. Your section, you will see finally Dr. Atiyah coming. And then complain to him, please, okay? Dr. Atiyah will come, will teach you only the lecture. The other section, I'll probably teach it because I have a commitment with the university. I have people coming from outside, I have to meet them. Okay? So next Tuesday, Dr. Atiyah will most likely teach you. Okay? I will try to teach the 11 and take a video. But please, don't embarrass me in front of Dr. Atiyah, okay? You can tell him the exam was hard, I don't care, okay? You know, you can tell him like that. Please make Major 2 easy. But he will explain from his own slides. We have 15 minutes. Hopefully we try to do as much as possible. So today we were supposed to start with this lecture. And it's what? 10:40. We're late. So that's why we need an additional lecture. The equations are exactly like of the resistive circuit. Node voltage is applicable. KVL, VDR, CDR, Ohm's law, mesh, super node, what else? Wheatstone bridge, you can have Wheatstone bridge, and everything is the same. That's why when you study for Major 2, you have to go back to Major 1. So it's comprehensive, okay? Major 2 is comprehensive of whatever Major 1. Exactly like of the resistors. Now, V of t and I of t, you convert them to what? Phasors. 100 angle 30, 2 angle 5, and you keep the units. The L becomes what? Z sub L. The C becomes Z sub C. The R stay the same. Analyze the circuit by using any of the techniques studied in chapter 2, and then perform it using complex arithmetic. The key game here is many students do not know how to do it in a fast manner. If you don't know how to do it, come to my office. Simple example. For find the steady state current, steady state, what did we mean by it? Just after some time, we're avoiding the transients. So don't get scared from the word steady state. For the circuit shown in figure 5.13, find the phasor voltage across each element. So from the expression given from the source, what's the phasor? Michelle, what's the phasor for that source? What is the phasor?
100 degree 30
Angle 30. What's the unit?
voltage.
Volts. Now we are professionals, right? What did we say the first step? Convert. So you can say this is 100 angle 30, and then we have a resistor. We keep it, right?
Yes.
Please, how about the inductor? What is omega?
500.
Always write, so always write omega here, okay? Because you needed to calculate 0.3. So 0.3 times 500. 150. I want to verify.
Yes.
So this is what J times 150. What's the unit? How about the capacitor? 1 over J omega C. All calculated. 1 over J times. What's the capacitance? 40 micro. 40 10 to minus 6. It's minus 50 J. Minus 50 minus J times 50. So now I can combine them into what? An equivalent. So I can have the voltage source, which is 100 angle 30, and then Fawaz,
Yes.
I can have the box now. You can write it as a box, which is going to be what? 100 plus J 150 minus J 50, which is what? 100 plus J 100. Okay? Ohms. So the question is asking you, find the phasor voltage across each element and construct phasor diagram. So let's find the current first. How to calculate the current.
The voltage over the
So I is 100 angle 30 divided by 100 plus J 100. What's the current?
0.683 minus.
We must have an angle, ya shabab, always. Now, sometimes if you type J 100, it's better to use I times 100, okay, in the calculator.
141 angle 45.
What?
141 angle 45.
I don't think so.
Give me another one.
It's 100 angle 30 divided by 100 plus 100 times J.
0.62. 0.68.
Well, it is, it's 0.68 plus or minus J times 1.83. صح?
Yes.
Minus J 0.183. What's the unit? Amp. So, what is V sub R? V sub R is R times I sub L, right? Passive sign configuration, do we have any issue with it? Plus minus, plus minus, plus minus. The current always enters from the positive. So V equal, I'm going to write a better formula. V sub R equals Z sub R times I. We call this I, okay? Not IL, we call it just I. Okay? Times I.
دكتور
Yes.
ليش ما كتبت الكرنت بطريقة ثانية؟ تقيس
It doesn't matter. This is equal to shift number 2 it is 0.707 angle minus 15. It's the same, it doesn't matter. You can use both. Okay? So what is Z? 100 times, let's use Mishal notation, angle minus 15, which is 70. Well, 70.7 angle minus 15 volts. So the voltage across the resistor actually has an angle of what? Minus 15. Same angle as the current. Okay? It's 70.7 angle minus 15. What is the voltage across the inductor? It is Z sub L times I, or you can call I of t. And it's equal to J150 times 0.707 angle minus 15. So it will equal to, let's use phasor notation, 106.05 angle 75 degrees. What's the unit? Volts. Is it the same? 106 angle 75. The last one is the capacitor. V sub C equals Z sub C times I, which is 0.707 angle minus 15 times minus J50. Minus 50 times J. Don't forget the signs, okay? You have to multiply by minus J50, not minus J50 times minus J50. And this is equal to 35.35 angle minus 105 volts degrees. 35.4 angle minus 105. Maybe we will not ask you to do this in the test, but I don't think it'll be required, but it may be required. I don't know yet. When you plot them, let's plot V sub R, so you have to do 70.7 angle minus 15. That's the current. VR is 70.7. The V sub S, it's what angle? 100 angle 30. V sub L is what? 106 angle 75. V sub C is what? Angle of minus 105. Minus 105. This is minus 90, a little bit above minus 90. Okay?
But sir, which one is leading?
It's a mess. Spaghetti now. But when you say leading or lagging, you have to look, for example, the voltage of the resistor and the current of the resistor, they are on phase. For an inductor, the voltage would lead IL. IL is not plotted. For the capacitor, the voltage will lead. So IC will be somewhere here. But it's not plotted.
لو بس أخذنا بي إل وبي سي أيهم اللي
Well, they have the same current. They all have the same current. So what VC is leading I, VL is leading I. So when you say leading or lagging, لازم تشوف الزاوية بين هون الحادة ومين اللي قبل. الزاوية الحادة بين I و VL هي 75 plus 15. The VL is قبل. The VC will I, because they all have the same current, is leading. So notice that the current I lags the source voltage by 45 degrees. So VS is leading. As expected, the voltage VR, they are on phase. For inductor, for inductance, the voltage VL leads. For a capacitance, the voltage lag. I'm sorry, I made a mistake. For VC, the I lead. For VL, the I. For VL, the I lag. VL is leading I is lagging VL. I is leading VC, VC is lagging I. And for VR, they are on phase. I'm glad we finished this example because Dr. Atiyah will probably cover similar examples more. And he might cover Kramer's method. I wanted to finish it today up until here, up until slide 37. So I would recommend you self-study, try to do these, read these slides during the vacation. Because on Tuesday we'll have 2 lectures where we will go over these examples in the other class that I will be teaching on YouTube. And then I will continue based on night. Dr. Atiyah will teach you, please come to the class. He will take attendance, he will take late attendance, etc. Okay? Yeah. Any questions not to be recorded? Recorded?